So hi, I'm Eric. I've been doing product management for Puppet for the last 6 years. Prior to that, I was a systems administrator, an SRE, and an occasional and probably terrible developer. I've been involved with Puppet in some way or another for almost a decade now, which is kind of terrifying when I think about it too much. And here's me in my natural habitat up in Portland, Oregon. I like playing electronic music with synthesizers and drum machines. And just like when you make a tweet that does numbers and gets a lot of retweets, I got to plug my SoundCloud there. So check that out if you're into that sort of thing. My talks are always a little weird for tech conference talks. This is probably because I came to systems administration sort of by accident and kind of a circuitous route as I was doing an English literature degree. I was hanging around the computer labs in between classes and was more interested in setting up IPX networks to play Doom than I was in doing my coursework. So I moved back to Honolulu, where I grew up, and started working in the early days of the commercial internet industry, back when 28.8 modems were a hot commodity. So hopefully this talk will be no exception. It's called Postmodern Puppet, which means I should probably start by answering the question, what does postmodernism mean? And I should probably back up before I do that and say, what is modernism? Before I do that, I should probably back up even further and say, where did modernism come from? Well, the roots of modernism were laid in the late 1800s as Enlightenment artists, thinkers, writers started to realize that the world was changing around them at an increasingly rapid pace. This is Vincent van Gogh, simply titled Self-Portrait with a Pipe and Straw Hat. It was a series of self-portraits that he did that allowed him to experiment with different painting techniques. So post-impressionistic artists like Van Gogh, Henri Rousseau, and Cézanne started moving away from this, the traditional idea of purely representational art, where the goal was to make your painting look as much like the actual thing as humanly possible. And instead, they treated the painter's impression, hence the name Impressionism, of what the subject looked like as having equal or maybe even greater importance with the subject itself. So you can see the brush strokes here on the painting. That was unthinkable in pre-impressionistic art because it would show that it looked like a painting. So this kind of exploration laid the groundwork for modernism at the beginning of the 20th century. And modernism dealt with a world that was, again, increasingly being affected by advances in technology. These had both positive and negative consequences. On the downside, advances in war and machine guns and those sorts of things led to destruction on a catastrophic scale, something that the world had never really seen before, and led in art to things like Picasso's famous painting Guernica. But on the positive side, new advances in things like materials technology allowed architects, Mies van der Rohe, for example, to build skyscrapers and floor-to-ceiling glass and things that were not previously possible given earlier construction mechanisms. So here's a pipe. As you can tell by the topics today, we're pretty obsessed with pipelines and pipes in general. This is Rene Magritte, and I want to give a shout out to Chelsea from the production crew who pointed out the fact that there is a Magritte exhibition just a couple of blocks away at SF MoMA going on right now. And I totally didn't know that when I chose the subject, but I'm excited to maybe be able to go over and check that out tomorrow. Magritte's an amazing artist who is almost sort of thought of himself more of a philosopher than an actual painter, although he's actually a very good painter. This painting is called The Treachery of Images. It kind of exemplifies modernism's examination of traditional forms. So there's a surrealist juxtaposition of something that clearly looks like a pipe with words below it that say, I'm not going to attempt French, it's not my thing, but it says this is not a pipe. And so the treachery of the images are that this looks like a pipe, but it is not a pipe. It's a representation of a pipe. And the words below it are also not a pipe. They're words that we associate with a physical thing that's called a pipe. And this, so the treachery in the title is the belief that these paintings engender in us, that the thing that we're looking at is the actual thing when it's not. It's just a representation. This set the stage for postmodernism, which was not only chronologically after modernism, but also provided a refutation or a rebuttal to a lot of the beliefs that the modernists brought. Postmodernism is sort of centered around the idea that things don't have meaning outside of the context in which they exist. that we make sense of those things by deconstructing them, by understanding the context in which they were created and tearing that apart in order to understand both the motives of the creator as well as our own interpretation of what that work means. So if we bring our pipe into the postmodern world, we get this, which is also not a pipe. This is a design by Rene Magritte, and it's a great example of remixing those elements to come up with something new. If you're interested in this sort of thing, I really strongly recommend a YouTube series by Kirby Ferguson called Everything is a Remix. He describes the creative process in a postmodern world as the process of copying elements from earlier works, transforming them in some way, and combining them into new context to create something that is actually new. And you can see all of that on display here, where we took the idea of a pipe and the Magritte painting and combined that with Super Mario Brothers and came up with something that is both amusing as well as maybe a little bit insightful. This is also not a pipe. So there's the framing for our progression. And you might be thinking, well, this is a marginally interesting and art history lesson, and it's great that you worked both Rene Magritte and Super Mario Brothers into a Puppet talk, but what does this have to do with Puppet? Well, I'm going to suggest that we are currently entering the postmodern phase of Puppet architecture and talk about how the various parts of the product have evolved through the 3 phases of development. So mapping roughly to these 3 versions of pipes, I'm going to say the classic Puppet period was kind of Puppet 0.24 through Puppet 3 and Puppet Enterprise 3.0. It was the early stages of the evolution towards what we have today, where a lot of the patterns were set. Things were still in development, but and moving really rapidly. Remember the response to increasing technological change, but we're still obviously dealing with that today. And the modern period, which is sort of Puppet 4 and 5, Puppet Enterprise 2015 through 2018, we developed into a mature stack in response to ever-increasing scale that our customers were drawing us towards, as well as changes in the external world, which led us to have to rethink some of the baseline assumptions that Puppet started out with. And lastly, the postmodern phase, which begins, I'm going to say today, with the releases of Puppet Enterprise 2019 and PE6, which came out a couple of weeks ago. Again, remember this idea of combining and recontextualizing previous themes into new kinds of synthesis. I'm going to focus on 3 broad thematic areas to talk through these different periods. The first one is the agent execution model. What is the agent? Where does it run? How does it run? Number 2 is the Puppet language. What is it and what can you do with it? And the third one is around our infrastructure as code and treating, as the Google guys were pointing out just a moment ago, how we can represent the infrastructure that we're running in a form that looks very much like application code. But first, this seems like an opportune time to introduce a little bit more about the new release. Omri mentioned that that PE 2019 is out today. Let me recap the past few months of Puppet Enterprise releases and Puppet development, just to catch you up to speed. In the spring, we released PE 2018.1, which was our latest long-term supported release. This is kind of the culmination of the Puppet 5 series of platform releases. It incorporates Puppet 5.5 and will be supported up until 2020. So that takes over from the previous long-term support release, which is getting a little long in the tooth. It's based on Puppet 4, and the PE 2018.1 release is a great release if you're in a position to want to upgrade off of the older 2016 release, but you're not quite ready to jump in the pool and take all of the new stuff right today as it's come out. The Puppet 6 pre-release builds have been out in the community since July, and the final release came out mid-September or so. And I want to give a huge shout out to the community members who have tried and downloaded the Puppet 6 stuff, run it in their open source installations. They've given us some awesome feedback on what we wanted, on how things were working for them and what we needed to change in order to make the upgrade more seamless. PE 2019 is available today for download. It's up on the download sites as of this morning. And the number's a little bit strange, maybe. We're introducing it sort of like an automobile manufacturer introduces the new model year in the fall, because this is where our focus of our new feature development is going to be over the next year. And we wanted to signal that it has a new major version of the platform inside of it relative to the PE 2018.1. There's a lot of great stuff in it, but I want to talk a little bit about tasks, since this is a very similar stage to the one I introduced tasks on almost exactly a year ago. And there's been a huge amount of development and advancement in tasks. Just to reiterate the framing for you, Puppet tasks is a way to run on-demand actions across your infrastructure. And it comes in two flavors. There's Bolt, the open source task runner, and there's a Puppet Enterprise Task Manager, which you see here, which takes the same physical task but provides scale out, provides role-based access control and governance and audit logs around that task execution across your infrastructure. There have been a huge amount of improvements in both flavors over the last year. The task metadata now shows up in the GUI. If I click the disclosure triangle that's highlighted there, you get hints on what parameters the task will take and how to make use of them. That uses the Puppet type system under the hood, so you can, for example, make a task parameter that only accepts a certain number of values, and those will show up in the GUI as, in the example here, as action. You can pick one of a few defined things that are contained inside the task metadata, so you can't feed tasks garbage and just have them run a shell escape or something like that across your infrastructure. Yasmin Rajabi, who's the product manager for the team that's implementing all this stuff, is going to have a talk in Sydney later on today about this and go into it in more detail. But one of the questions that has come up a lot lately around tasks is, how do I know when to use which approach? We now have the idea of tasks as an independent thing. We also have our traditional sort of state management of Puppet code. And as Omri mentioned earlier, and as I'm going to talk about in a moment too, we now have the ability to embed traditional Puppet modules inside of a task plan. And the question becomes then, tell me when I should use which approach. For me, it really comes down to, it's not, they're complementary to each other, and it's not either or, it's sort of a both and. And the key component is really the dimension of time. You can ask yourself, how often am I going to care about this thing? Is it something that's one and done and I'm never going to have to worry about this again? Is it a troubleshooting task that I may get some reuse out of the task, but this particular sequence is something that only happens once a month? Or is it something that's more like a compliance baseline where I need to enforce it all the time forever across my entire fleet? Things in the former category lend themselves more to a task-based approach, and things in the latter are more like state-based management. There's lots of other great stuff in Puppet Enterprise 2019, but I'm personally really excited about these task improvements and wanted to highlight them. So let's go back to our art history here. To talk about the agent execution model a little bit. Classically, Puppet ran as a daemon. It woke up every 15 minutes or every 30 minutes and checked in with the master, got a catalog, applied the catalog, and sent in a report. That worked really well for a lot of people. But over time, as Puppet got more sophisticated in the capabilities that it could do, people wanted a little more control over when and where it ran and what it did when it ran. So we shifted in the Puppet 4 and 5 era to develop the idea of a direct change workflow, where you might do triggered, ordered execution across your nodes. A lot of folks adopted the pattern where they would run as a daemon, but run in no-op mode all the time so they could see what was going on across the infrastructure, but Puppet wouldn't actually make any changes until, say, a maintenance window opened. And then they would do a enforcement mode run that caused those changes to be remediated. In our current world, we're moving into this idea, as we've been talking about the combination of tasks and state, and blending the lines and recontextualizing things so that, for example, you can run a Puppet module, but run it as a one-time event without necessarily including that module in the agent's catalog to run full-time. And I think this is an important shift that again lets you blend the two approaches and pick the right thing for the job that you're trying to do. And again, provides us a new context to some of the technology that we've been developing over the past few years. This is the task plan that Mike Stonke presented earlier, and this is sort of the epitome of that approach that I'm talking about. I'll walk through this just in a little bit more detail to describe what each of the lines do. That line 2 is more or less what I just explained with the pull down. We say that there's a enum that can only be present or absent, and it defaults to present. So you get the great Puppet language constructs that you're used to from classes, but they're now inside of a plan wrapper instead of being inside a class. The apply prep is sort of like a pre-flight check that actually goes out and gathers facts across your nodes and gets ready to run the rest of the plan. We then do an apply across those nodes, which uses the profile : firewall class and actually goes out and transfers the code over and evaluates that class on the nodes one by one. And then at the bottom of it, we do sort of a check that uses the bolt style command execution to log into those nodes, run a single command, and then represent the output back to you. One more plug for a talk later on today. Lucy Wyman is talking in Amsterdam. She's one of the developers on the Bolt team and has a great talk lined up that goes into a huge amount of depth about how to use this, how to take modules that you're already using for classification style Puppet runs and move them into Bolt plans. So I think that may come up a little bit late for us. I think that's going to be about 4 in the morning here in San Francisco, but it'll be up on YouTube afterwards, so please do check that out. Next up, the Puppet language. Back in ye olden days, we had the sort of a classic parser that could do pretty much anything and everything. There was a lot of behavior that was emergent from that people developed patterns around, but it wasn't necessarily specified. In the Puppet 4 era, we moved to using the future parser, which is now the present parser because we now live in the future. It's 2018, and while we don't all have jetpacks, we have motorized scooters, which I think is basically the next best thing. And we have a type system, which I've shown a couple of examples of, that lets you have really didactic say about how your variables ought to look. It allows you to get rid of a bunch of boilerplate code that would test for empty variables and determine whether or not things were defined or not before erroring out, and lets you catch those kinds of problems very early on in the compilation process. That, however, introduced a big discontinuity into the ecosystem because there were things that worked in the classic parser did not work in the future parser. We learned a lot of lessons about that, tried to soften some of the errors and make some of the behaviors work in both the old and new contexts. And the line that I've been holding since Puppet 5 came out is that we're not breaking the language anymore. In terms of the language, it's pretty much done. It's in a good shape. It works in lots of different contexts, and now the goal is to really make it so that we can add new things into it in an additive way rather than in a break the world kind of way. There's 2 main examples: task plans, which I just showed you, and the new thing that Omri alluded to earlier today around secret management. I'm going to talk about that in a little bit more detail because we had a very brief allusion to it, but I think it's a really awesome, powerful feature. And it does represent, going back to the theme, a recontextualization of something that's always been there in Puppet. Parser functions have been around since the earliest days of the Puppet compiler, but now they can run on the agent, as the name implies. How does that work? Well, previously, if you wanted to look up a secret in, say, Vault, you could only do that as the catalog was being compiled. Puppet Master would look it up. High-rate YAML is another example of this, where you would look up the secret as the catalog was being compiled, and then that secret would be input into the catalog and transmitted out to the nodes. Now with agent functions, you wrap that Vault lookup, as you can see in the middle of the screen there, with a new data type that's called deferred. And deferred tells the compiler not to try to run the function itself, but rather to, as the name implies, defer it until the agent receives that part of the receives that catalog. When the agent receives the catalog, it sees that there are types that are left in it that are called deferred, and there are functions. Functions are now plug-in synced down to clients, so they're available for the clients to make use of. And the clients then go through and resolve those function calls by looking up the secrets, in this case, directly against the secret storage. This allows you to have much better chain of custody for those secrets. We're not exposing them in the middle of the chain, and it allows each of those agents to only have access to the secrets which they are entitled, rather than having to have the master be able to get at all the secrets for all the agents that it compiles catalogs against. So this is available in Puppet 6 in open source. It's available in Puppet Enterprise 2019. The initial targets for integrations are around the HashiCorp Vault, around CyberArk's Conjure, and against the Azure Key Service. It's really easy to add new integrations to make the lookups work against new kinds of secret storage, and potentially to do additional things outside of just the secret storage use case, although that's kind of the primary and initial target for what this feature is aimed at. Pretty excited about this. Our last area is around infrastructure as code. So classically, we had the ability to run parser validation and see syntax errors if you had something that was obviously wrong in your manifest. And as far as code and data separation goes, the idea that you should have the inputs to your code be separated out and be able to change independent of the logic, the conditional logic and the control flow of the code itself. The earliest examples of that were XLOOKUP. Are there any XLOOKUP users out in the audience? A couple of folks that have been around since those days. It was a great idea. It was really a way to do hierarchical lookups, and it used comma-separated values in different files, so probably not the most sophisticated implementation, but it certainly worked, and it solved it was an initial cut at solving that data code separation problem. XLOOKUP evolved into Hira. Are there any Hira users out in the audience? I would imagine most everybody's using that now. Yep. And I want to give a big shout out too to Ari Pinar, who was the original author of Hira and promulgated a lot of the patterns that people use today for using Hira and for getting that code and separation from their data and their code. On the infrastructure as code side, a tooling ecosystem began to emerge around Puppet, mainly around R10K, which allowed you to map branches in your Git repository onto environments on your Puppet master. And this mapping allowed you to use Git workflows and code management workflows like merges and creating new feature branches and those types of things, but apply them directly to your Puppet code. We had an emerging ecosystem as well of testing tools like RSpec Puppet that allowed you to, again, run your Puppet code through a series of tests before putting it out, thereby getting an ever greater amount of assurance that the code was going to work as you expected when it hit production. Up to the present day, we now have a formally supported PDK that bundles up RSpec Puppet, lint, and other validation tools into a supported multi-platform, really high-quality IDE type experience for testing Puppet code. And Hira has evolved into Hira 5, which has a new implementation that allows you to reuse your same hierarchies if you want to, but adds things like the ability to trace the value as you do a lookup through Hira, so that you can see why a particular lookup got the value that it got, which is an invaluable tool for debugging complicated Hira hierarchies. It also allows you to have more flexible backend support so that you can have different backends per layer of your hierarchy rather than having to traverse the entire encrypted YAML backend before you start looking at the unencrypted ones. And lastly, in terms of the evolution of the testing ecosystem, we have CD4PE, which Mike demoed earlier. This is sort of where the buildup for all those different pipe jokes has been heading. So this is the main screen of continuous delivery for PE, or CD4PE for short, because that's kind of a mouthful. And in addition to the impact analysis, which Mike demoed earlier, I wanted to point out two key features of this. The first one is that CD4PE can handle both control repositories, which have a listing of all the different Puppet modules that ought to be in your environment at particular versions, as well as manage the testing and promotion workflow for individual code modules, which obviously manage a particular piece of your infrastructure. Those are handled slightly separately because the testing of them and getting assurance about them works a little bit differently, but they're both, you can manage both kinds of repositories inside of CD4PE. The second cool thing is that the pipeline itself on the right-hand side is extremely configurable. In this case, there are several different validation steps, and just like you would with an application testing pipeline, you want to do the cheap checks early, so that if they fail, you kick out a bad change as early as humanly possible, and don't waste your time and compute cycles running really complicated or expensive tests on something that just isn't even going to pass the smell test. So in this case, we're running validation tests and spec tests very early. We validate the higher syntax, and only if all of those pass do we go into that impact analysis, since that's obviously a little more complicated and computationally expensive. After we pass impact analysis, we now have a pipeline that connects up that code once it's passed into a deployment. And this is also highly configurable. So if you in your environment have multiple user acceptance testing environments, you can set that up here. If you have policies which require a manual or a external approval before a code change actually goes out to production, but earlier pre-production environments are okay to promote through manually, you can configure all that inside CD4PE. This is a great application of the pipeline's technology into the specific use case for testing and promoting Puppet code. And it's really pretty cool. I encourage you to check it out. So I'm running short on time, and I wanted to just close with a couple of thoughts. So the question is, what's after postmodernism? And the answer is obviously postmodernism. This is David Foster Wallace, who is often described as a postmodern author, but in fact, he rejected postmodernism's reliance on ironic distance. And I'm going to read this quote from him. "Sarcasm, parody, absurdism, and irony are great ways to strip off stuff's mask and show the unpleasant reality behind it. The problem is that once the rules of art are debunked, and once the unpleasant realities that the irony diagnoses are revealed and diagnosed, then what do? All we seem to want to do is keep ridiculing the stuff." David Foster Wallace suggested that postmodernism be about the new sincerity, the idea that once we're past ironic distance, the idea that authentically held beliefs in things that are good is actually a strong antidote to the nihilism that is produced by excessive postmodern distance. For us, we had to have the model, and we had to sort of break it down, and I think now we need to reunify behind it. Abstractions and reusability are key for managing complexity, regardless of what the infrastructure problem is that you're trying to solve. I think agentless is going to continue to advance into ever more sophisticated forms of implementation. The ultimate goal would be to get reuse of the existing ecosystem of Puppet content without having to have a footprint on remote systems. It's a ways out, but that's kind of where I think this is headed. Similarly, cloud-native management is an area of intense interest. What does it look like in order to manage resources in a declarative way when everything is just an API endpoint and there's not a system on the remote end at all? How do we make that portable across different clouds and across container runtimes? For us, the most important thing is to continue to make your lives easier in this chaotic world and to empower you to do more of what you love. Again, authentically held beliefs and things that are good and positive. In closing, I'd like to share a comment from someone who represents not the new sincerity, but I think the original sincerity, a timeless sincerity, who has a message that I really needed to hear, and I hope that it helps you too.
No matter what our particular job, especially in our world today, we all are called to be tikkun olam, repairers of creation. Thank you for whatever you do, wherever you are, to bring joy and light and hope and faith and pardon and love to your neighbor and to yourself.
That's all I got. Thank you.